Hello. Today in this video lecture we will see numerical on maximum and minimum stresses. So see how to solve this numerical. First understand numerical thoroughly. That understanding point is very important, and after that see what they had given us in numerical and what we will need to find. And so for that first I will read this numerical and I will explain through diagram what they had given and us and what we will need to calculate. So first understand. Focus. A rectangular column of width 200 mm and of thickness 150 mm carries a point load of 240 kN at an eccentricity of 10 mm as shown in the this figure. Determine the maximum and minimum stresses on the section. So we will have to find maximum and minimum stresses for that rectangular column. So here first see given quantities that see here, that is elevation of this column. This total is elevation of this column, and they had they told us that this is width 200 mm of that column, and apart from that this is thickness. This is nothing but the that cross section of that column. Either you can talk like that elevation of top view of that column. So that 150 mm is thickness of that column. Generally we talk it as a depth, but they had given us a numerical as a thickness. So this is 150 as a thickness, and see here this is point load acts on this column. This point load is act like a eccentric. So focus, this is eccentric point load, and eccentricity from centroid is this 10 mm. So those are all given quantities, and see shape of that column section is rectangular because one side is 150 mm and other side is not similar to that 150. It is greater than that 150. It is 200 mm. That's why it is rectangle. So now see our objective. Our objective is to calculate that maximum and minimum stresses. So we had seen that maximum stresses is denoted by sigma max, and formula of that maximum stresses is P by A, load upon area, into 1 plus 6 into eccentricity by width of that column section. Width nothing but this B width. That means this 200. And our other objective is sigma minimum, P by A into 1 6C by B. Everything is similar, only here minus sign will come. So that it is. And that sigma max is nothing but this is applicable to, see this is section of that column. Consider this section as anywhere, see bottom, that means this sigma max acts for all of this portion here linearly like that, and this sigma minimum act as here all of this portion. So I will tell you this, no need to bother about it. So first write our data. That means given quantities. See given quantities, this 200 mm width, this 150 mm thickness, and this point load 240 kN, and this eccentricity 10 mm. So data is equal to width B is equal to 200 mm, thickness is equal to 150 mm, and point load denoted as capital P is equal to 240 kilonewton. That means kilonewton, convert it into Newton, 240 into 10 raised to 3 Newton. Eccentricity is equal to 10 mm, and now our objective to find sigma minimum. See in numerical they wrote it as a maximum first, so sigma maximum first, then sigma minimum. And I told you mechanics behind that column eccentric load. See, due to this load, this side of column like drops down, so that's why here always like this, always. So sometimes here compressive forces comes, and sometimes here on this side tensile forces comes. So we had seen that derivation. Now we will see exact values of that stresses. Now move towards solution. Eccentricity minimum is equal to load upon area. Load, eccentric load acting on that column. Area is sectional area of that column multiply by, see here in this formula is multiplication size, 1 plus 6e upon b. Always see formula enthusiastically that P is eccentric load, it is directly proportional to stress. A is C, A is area of that section, column section is inversely proportional, and here multiplication sign again that 1 plus 6 into eccentricity. Eccentricity is in numerator, width is in denominator. So see like that, then you will remember it. So this P is 240 into 10 raised to 3. Area is, sectional area is that 150 this side and 200 this side. 150 into 200 into 1 plus 6 into eccentricity is 240 kilonewton. Sorry, eccentricity is not 240 kilonewton. 240 kilonewton is eccentric load. Eccentricity is this 10 mm. And B width of that column again is this 200 mm. That means this side. Remember that. Don't make mistake here. It is B, not area. This is minimum stress. So this minimum stress now we will calculate by using that engineering calci. 240 into 10 raised to 3 divided by 150 into 200 into 1 plus 6 into 10 divided by 200. So it is 10.4 and unit is Newton per mm square. Why unit is Newton per mm square? Because all over that sigma minimum values we put it as a Newton and mm square. So that's why this is in Newton per mm square. See, again we had make mistake. If this is plus, that means this is sigma maximum. This is not minimum. Remember that. Not minimum, maximum. Formula of sigma minimum and maximum are different. And what is different between that formula? Only sigma minimum formula, here minus sign will come. Remember that. So sigma maximum is equal to P by V into 1 plus 6C upon B is maximum stress formula. And this maximum stress is correct stress. See here, this is solution of that problem, and here on that side maximum stress 10.4 Newton per mm square. Now calculate our second objective, that is sigma minimum stress. Minimum stress formula is load upon area into 1 plus 6 into eccentricity for that load between centroid and that load upon B width of that column. Again P is that 240 into 10 raised to 3 divided by area of that sectional area of that column is 150 into 200 into 1 plus 6 into eccentricity is 10 mm and width is 200 mm. Sorry, see here again this is not plus, for minimum stress it is minus. So calculate this, 240 into 10 raised to 3 divided by 150 into 200 into 1 minus 6 into 10 divided by 200, so it is 5.6. See here sigma minimum 5.6, so yes it is correct, 5.6 Newton per mm square. Why Newton per mm square? Because our P is in Newton per mm, sorry, P is in Newton, and area and eccentricity and width all are in mm, so that's why. And stress unit is that Newton per mm square, kilonewton per meter square, like that, so that's why. So see like that, and see remember that our stress comes in positive, so when it comes in positive then that stress always in compressive in nature. So see our sigma minimum stress is also in compressive and maximum stress is also in compressive, because maximum stress is also positive. If it will come in negative, that means this will be tensile. So remember that negative stress, that means tensile stress. So see articulation of that stresses, that compressive stress, that means like draw it like upward arrow. See this is unit is also always right. Unit is important because unitless value is senseless, so that's why. So see here, so see this stress 10.4 Newton per mm square. So this is for this region, and minimum stress 5.6 Newton per mm square, this is for this region. Why on this portion stress comes minimum? Tell me that reason. Because see this eccentric load is act on this side, and if it act like eccentric load acts like that, this column will like shift like that. So that's why this side is always in more compressive. So that is the reason that load is acting on this side, so that's why this compressive stress is maximum here and here it is minimum. So like that way we had solved our numerical. So thank you very much.